Hello everyone, welcome to Question Coder. So in this video we will see this question, that is 347, which is top k frequent elements. So it is a medium level question and it has also been asked in various interviews for Amazon, Facebook and Microsoft. So let's see the problem statement. Given a non-empty array of integers, return the k most frequent elements. So as the word frequent has come, so that means we will have to calculate the frequency of the elements. So you can see this is our input. This we are given an array of input, so it will be 1 1 1 2 2 and 3. So we have to return the k is 2, so we have to return the k most frequent elements. So k is 2, that means we will first of all count the frequency. So its frequency will be 1, its frequency will be 3, and 2's frequency will be 2, and 3's frequency will be 1. So the most occurring elements, or the elements arranged in the decreasing order of their frequency, we have to return the topmost elements. So that will be k topmost elements. So that will be 1 and 2, because 1 occurs 3 times and 2 occurs 2 times. So they are the topmost you can say frequent elements that are occurring. So we have to return the k elements. So there will be 2. So if we are given only a 1 element, then and k is also 1, we can simply return 1 element. And here are some notes. So you may assume that k is always valid. So which states that if we are given like array of size 2, then k can never be of size greater than 2. That will be k can never be 3. So k is always between the bounds of 1, and actually it is between the bound of number of unique elements, because k matters as number of unique elements. If k is here, if for example k is given 4, but unique elements only are 3, because 1 2 3. So there won't be any four most frequent elements, because there will be only 3 elements. 3 unique elements occur only in that. So your algorithm's time complexity must be better than O of n log n, and where n is the size of the array, and it is also granted that the answer is unique. In other words, the top k frequent elements is unique and you can return answer in any order. So let's see and how to solve this question. So actually you see, this is the example that we were given. Okay, so let me write that. So this was the example that was given, and if you try to see, we have to calculate the frequency of the elements. So the which data structure comes to your mind when you have to calculate the frequency? So that is simply a map or a dictionary in Python. So you can simply use Hashmap to calculate the frequency of the elements, and then we will do some sorting or something to get the topmost key elements according to their frequencies, or decreasing order of their frequencies. So let's see. So first of all, what is Hashmap? If you don't know, Hashmap is simply a pair of data structure containing the values as key value pair. Actually, if you see, it is a data structure consisting of key value pair. So what will be the Hashmap actually having? What will be the elements that we will having our Hashmap? So actually we will iterate over this array, and we will save the elements as the key, and their value will be the number of time they occur. So if we iterate over this array, so first we check this one. So it is not in the Hashmap, so we add it here. So its frequency will be 1, because it has occurred 1 time. Now if we go to next element, if we iterate and we go to next element, so again 1 occurs. So 1 will be already in the map, so we will simply increment the occurrence of that, so its value will be incremented. So key is actually 1 and value is 2. That means that our key 1 occurs 2 times till this point. Now again 1 will occur, so this value will be incremented. Then if you see, then 2 will occur. So 2 will be not the Hashmap, so we will have to include the 2, and its frequency will be 1, because it has occurred 1 time. Then again 2 occurs, then its frequency will be 2. Now if you see, again this 3 occurs, so 3 is not in the Hashmap, so we will have to add the 3, and frequency will be 1. If you are thinking that we already have this in sorted order, but that won't be a case, because if we are given in this array it is already sorted, but we will be given like 1, then 1 will occur here. So then your order will change maybe. So if 2 occurs before this one, and then 1 occurs here actually, so your order will change. So your this will come after this. So for doing that, what we have to do is we have to sort these values according to their this frequency, or you can say value. We have to sort these keys according to their frequency and return the topmost k keys. So how we can do that? So the basic data structures that will come to your mind is using a heap, because we have to return the topmost elements. So we can use simply a heap actually. Let me select this marker. So we can simply use a heap, and our heap will store the elements as a key value pair, or you can say simply a pair. So it will store a pair. Each element will be a pair, so it will be 2, 2, like for example this. So this is how we will store the elements in our heap. So we will actually store the elements as the key value pair only. So it will be like 2 and 2. Then we will have the pair like 1 and 3. So we will sort, or you can say the heap will automatically sort the values according to this frequency, actually not this the key, this frequency. These are the frequencies, this 2 and 3 are frequency. So heap sort will accordingly sort these values and using the frequency. So we will have to it actually by default sorts the value according to the first value in the pair. So we have to keep the first value as the frequency in the heap. So let's see how we can do that. So first of all, we also need to determine which heap we will be using, that is min heap or max heap. So in this case I am using the min heap. So actually what I will do is, it is written that we have to increase our time complexity, improve our time complexity, and it should be at least better than n log n. So if I use min heap, for example, if I use min heap, so I will do one thing, that is I will keep inserting the values, and if the size of the min heaps get greater than this k, so we will simply pop that element. So at max our heap sort is of size k is equal to 2. So actually heap sort will be at max of size 2, so which will improve our time complexity. And if we see, the function of heap sort will become log of k. So log of k will be always less than n. You can see it will be less than equal to n, because worst case will be k is equal to n. So it will become then n log of k. So that will improve our time complexity, and it will become better than n of log n. So let's see how we can do that. So we will simply traverse over this map. So we will initialize a heap. So it will be actually a min heap. So we will initialize a min heap. So let's see. So we are traversing this map. Okay. So we are traversing this map, and we can assess these values as if our traversal is like I. So okay, our I is our iterator. So we can assess this key as I dot first, and the value as I dot second. In C++ I'm learning. In Python you can simply see your syntax. So in C++ it will be assessed as I dot first. Okay, I dot first we can assess like that. Okay, I'm not writing it here. So let's see. So when we start traversing this map, okay, we have initialized a heap. Okay, we have initialized a heap. Now we traverse over this map. So we see value is 2, 2. So value will be 2, 2. It will be written as this. Okay, then we will come to this point, and we will also check when we have added a value. We will check if the size of heap is less than if size of the heap is greater than k, then we will pop the element. If it is not greater than k, then we will do nothing, and we will simply keep the value added. So now we come to this point. So 1 and 3. So 1, 3 will be added. So 1, 3 will be added at this point first of all. So it will be added here. Now heap will automatically heapify this, because this is a min heap. Okay, so if you see, actually I'm doing something wrong. So actually if you see, we are storing the value as the frequency and the value pair, not okay, this frequency and the key pair. If you see, I told you we have to sort the values according to the frequency. So frequencies of this are 2, 3 and 1. To do that, by default heap will automatically take the first value or the first value in the pair as the key to sort. So we have to keep the frequency as the first part or the first pair element. You can see, so 3 will come first. So if you see, now this is our min heap. So 3 will come here. Okay, 3 is here, 2 is here. Now it is automatically heapified, because you can see 2 is smaller than this 3, and it should come at top in the min heap. So it is automatically okay, correct. Now we will come to this point. So it will be 3 and 3, 1. So now if you see, the value will become 1, 3, because we have to keep the frequency before the actual key. So 1, 3. So if we add this 1, 3 here, so let's see. First we are adding the element. We are not checking for the size of the heap. First we add the element, then we check for the size. So it will be added as 1, 3. So 1, 3 is added. Now if you see, this 1 is, we are sorting this based on this first element. So you can see 2 is less than 3. So this is correct. But when we add 1, so in heap actually we add the values as this first root is added, then this, it is actually added in left to right order, and no value is skipped in between. So it is actually added in this order, left to right, and no value is skipped. So now this is added. Now it is breaking the law of heap, or you can say the property of heap. So the main heap, the minimum value should come at the top, and it should be root. So it is not the case here. So we will simply, it will come coming here. So now you can see it will become 3, 1. Now here it will be 1, 2, 2. So now you can see heap is automatically heapified, and it is sorted in a you can see using the frequency. So it is coming 1, 2, 3 and 2. So 1 is smaller than the root is smaller than the children. So this is the min heap property. So you can see it is correct. But we will check then after adding the value, we will check if the size of min heap is greater than k. So yes, the size of min heap is 3 actually, and k is over 2. So it is greater than k. So we will simply pop the root element. In heap we can only pop the root only, because it cannot be like we pop any child. So it cannot be done. So we will pop the root. So root will be pop. So what will be our heap now? So it will become 2 comma 2, and then it will be 3 comma 1. So you can see we have simply left with the maximum occurring elements only. So now what we'll do is our size of k, our size of heap is k only. So we can simply add these values into our result array. We have got our result. We have to find the k most elements which are occurring the most number of actually times. The frequency of elements that is higher. So it will be 2 and 3, 1 only. So it can be in any order as it is written in the question also. It can be in any order. So we can simply return 2 also before this one. So then we will traverse over this heap, and while the size of heap is greater than 0, we will simply keep adding this elements into our array. So it will be, we don't have to add this element. This is actually the frequency. So it is a pair. So we will assess this second element. So 2 will be added, then this 1 will be added, and we have got our result. You can see 2 and 1 is our output. So it can be returned in any order as it is written. So you can return this 2 and 1, it will be correct. So this is what we will use in our algorithm. Actually this is our total algorithm that we'll be using. So first to summarize, first we will make a map. Then we will iterate over this array, and then we will set the frequencies of all elements, add the all elements into the map. Then we will initialize a min heap, then add all the elements into the min heap, and if at any point the size of the min heap is greater than this k, then we will simply pop the element. And afterwards, when our loop is done, we have iterated over the whole elements of the map, then we can simply add all the values in the heap to our result array. So what will be the time complexity for this? If you see, the time complexity will be n of log n, log k, because we have to optimize this to log of n of log k. We cannot do it in O of n log n. You can see it is written must be better than that. So why it is k? Because at any point we are popping the element whenever size of heap gets greater than k. So when we heapify our this heap, so it will be heapifying only the k elements. So time complexity for this will be log of k, and n is for traversing this, because we have to traverse. So you can see this will be our time complexity. So for summarizing, n will be, because we are creating a map, so we have to traverse for the whole array at least once. So it will be O of n log k, because we are heapifying min heap, but it is of size, at most it is of size k only, because if its size increases than k, then we simply pop the element. So it stays it stays at size of k. So the space complexity will be n plus k. N will be for the map, or you can say for the map only, and the result, and the k will be for heap, because our heap is of size k. So let's see the code. I will show you the code in C++, and I will also share the code in the description also, so you can refer the code from there. So the base condition for this will be actually if our size of this array is less than 2. So it is written there, you can see. So if size is like 1, so k is also 1, so you can simply return the 1 element. So you can see we will return the numbers of 0. So now we have initialized the result variable, and this is how we initialize a min heap in C++. So actually it is a priority queue. So we will initialize it as priority queue, and we have to make a pair of values. So as you know, we have to make it as a pair of this frequency. Okay, this is the frequency and this is the key. For example, 3 is the frequency and 1 is the key. So we have to initialize a pair of int and int, and this is the syntax again for initializing. This is the syntax for initializing the min heap. Otherwise it will become a max heap. So it will be vector of pair int and greater pair int. So this is our name of the heap. So it is min heap. So then we will initialize an unordered map. So unordered map will have values, key as int, and values will be also int. So it is named that MP. So you can see we have to create a map also. So it will be also having the pairs. So then we will iterate over the array. So this is when I will run from 0 to numbers dot size, and we will keep adding the value of the elements, actually, or values to the keys in the map. You can see numbers of I plus plus. So it will actually add this value. If it is not there, that like 2 is not there in the map, so it will add 2. Then it will automatically keep incrementing the 2 if it occurs again, the value of 2. So this will be creating our map. Then we have to iterate over this map and add the elements to our min heap that we have created. So then you can see I will used auto iterator. This iterator will iterate over this map. Then to assess the values of the map, actually the value and the key, as I told you, we have to use this first and second. So second will be actually our value. This 2 is assessed by this second, and first will be assessed by 2 and 1. So as I told you, in heap we don't use the keys or this keys actually, or the elements 1 2 3 as the this sorting element. So we will have to use frequency for them. So when we have assessed this value, so you can see we will add this into our main heap. So main heap dot push, this is the syntax for that, and for adding it as a pair we have to write this curly braces. You can see curly braces it, it is our iterator dot second. So second will be actually the frequency of the element, and this will be our key or the element in the array. So it will be it dot this first. Then we will add it, and at every point we will check if the main heap size is greater than k. So we have to keep it at most at size of k. So we will simply pop it if it gets greater than the k. So you can see to satisfy this condition, actually to make it the time complexity better than n of log n. So this will be what we will doing. So at last we will be only left with the k elements or the k most frequent elements. So we can simply iterate over this heap and main heap. Then while its size is greater than 0, we will add it to the result vector that we have created, and we have to add it as main heap dot top and dot second, because first one is our frequency, it is not the actual element. So actual element is the second in the pair. As I told you, it is the second value in the pair. If our pair was like this, you can see it is the second value. So this is our element that we have to add. Okay, so this will be the whole algorithm or whole code for this k frequent elements, top k frequent elements. Then at last will return the element, and don't forget to this main heap dot pop, because we are using the top value, so it is actually giving me the top value but not removing that. So let's submit this code. So I hope it works. So I will share the code in the description, and guys, do like this video and subscribe this channel for more such videos. So you can see it ran faster than 94.13% of solutions, and it took less memory than 8.91% of solutions. So thank you for watching, guys.